Okay, so sometimes when we are differentiating trig functions, we are going to have to use some of our formulas, our identities that we met in trigonometry. And they can be found on your log tables, and I've just taken a screenshot here of the pages. I think they're around page 8 or 9. So step 1 here, it says differentiate if f of x is equal to sine for x plus cos x, and I'm going to say this is to the power of 4 here. Okay? So f prime x, so another way of asking. Now, I'm going to first of all focus on the sine x to the power of 4. So we know that another way to write that is sine x all to the power of 4. So what I have here is I'm going to let y equal the inside bit, which is v to the power of 4. And then I'm going to let v equal sine x. So let's differentiate that bit first of all. So bring down my 4, so dy dv is equal to 4v to the power of 3. And then dv dx over here, so sine to the power, or sine x, what does that go to? So I have the differentiated versions here. So this is f of x, and this is f dash x, and this is from my log tables. And I can see that sine of x goes to cos of x. So when differentiated, that's going to be cos of x. So go back, bring both together, because dy dv times dv dx gives me dy dx, which is what I'm looking for, differentiated. So it's going to be 4 bracket, instead of writing v, I'm going to write sine x to the power of 3 times cos x. So remember, throughout all of that, all I did here was I worked out sine x to the power of 4. So I've still got to do this plus cos x to the power of 4. So let us sort that out. So that's the sine x to the power of 4 cos x to the power of 4. So we know ourselves that another way of writing that is cos x all to the power of 4, which gives us our inside and outside section. So it's our chain rule again. So y is equal to v to the power of 4, and then I'm saying v is equal to cos x. So dy dv equals 4v to the power of 3. dv dx is equal to, let's have a look and see what that gets. So when you differentiate cos x, you get minus sine x. So let's write that in, minus sine x, and let's bring the two together. So it's 4 times cos x, bracket minus sine x. And I could probably just do a little bit of cleaning up here. Minus 4 sine x cos x. Okay, so that's one answer, and this is plus the answer that we got here, which is 4 sine x to the power of 3 cos x. Okay, so you're probably spotting that I can rewrite that as a minus, and we can figure out that there is a 4 common in both. So I'm going to take out the 4, but then I also spot that we have a sine common in both, and we have cos common in both. Okay, so now before I do anything here, I've just spotted a little mistake here. It was 4v to the power of 3, so I should have my 3 there, and so that should be a 3 here. Okay, so I just had forgotten that. Right, so let us focus on taking out the 4s. I can take out the 4s. I can also take out 1 sine x, and I can also take out 1 cos x. So I've got 4 sine x cos x, and then in brackets I am left with sine squared x. Okay, because remember there's 3 of them here, so I've taken out 1, so I'm left with 2, and I'm also left with 2 cos. 2 cos, or cos squared x. Okay, and at this point I want us to look at sine squared x minus cos squared x and think back to our trigonometric days and spot, can we spot anything? So let me. Okay, so I've brought the identities just up here, and we have sine squared minus cos squared, and you can see it's very similar here to cos squared a minus sine squared a, just missing the minus. So actually we can rewrite all of this as minus cos 2a or 2x, seeing as that's what we're dealing with here. And then what I'm going to do here is I'm going to take out the 2. Of course, so factorise that, take out. So it's 2 times 2 sine x cos x. Now, do we have anything for that? We do. So that's equal to sine 2a. So that gives me 2 times sine 2a, or we'll call it x, seeing as that's what we're dealing with, bracket minus cos 2x. And so we're looking at that and we're spotting anything that we can see. So I'm going to just rewrite that as minus 2 sine 2x cos 2x. So if we look here, we know sine of 2a is 2 sine a cos a. So we're going to use this one to work backwards. So sine 2a is 2 sine a cos a. So minus 2 sine 2x cos x has a similarity to that, all right? So if you have a look at where your a's is and what happens, the number in front of the a here. So we can see here the number 1 doubles to a 2 and the number 2 halves. So if I have this already, I'm working backwards. So if you do a little bit of jigging around, you're going to get sine of 4x. That's what that means. And we still have our minus, so it's minus sine 4x. So what we're looking at today is we're looking at using the identities here that we met in trigonometry to finish off some of our differentiation, so to make it look a little bit nicer. So this is what we got to when we differentiated, and then we spotted some similarities with the identities to make it look a little bit nicer. Okay, so our second question today is this one here, and it says the graph of the function f of x is equal to cos x sine x, where x is less than or equal to 2 pi and greater than 0. They've drawn this for you here, so you can see here's the y-axis between 1 and minus 1, and they've drawn what the function would look like. So it is hitting the y-axis, sorry, it's hitting the x-axis at pi, and then repeating itself at 2 pi. So show that f dash x is equal to cos of 2x. So we know that f dash x is equal to f of x is equal to cos x sine x. So what we want to do here is, I suppose, acknowledge that this is the product rule. So we have one multiplied by another. So I'm going to call that one u and that one v. So what is the product rule? Well, I'm just going to write it down quickly. Okay, so if y is equal to u multiplied by v, the differentiated version is the first differentiate the second plus the second differentiate the first, or the other way around either, because it's commutative. So I have this written down here, and I'm going to start off straight away. So I'm going to first of all work on cos of x. Okay, so I have u is cos of x and v is sine of x. So du dx, when we differentiate cos, okay, so I have it there on the left. So when you differentiate cos, it goes to minus sine x. So that's obviously what we're going to get here. And then when we differentiate sine, it just goes to cos of x. So I'm going to write that down. Okay, so now let's apply this rule here. So the first one is the first differentiate the second plus the second differentiate the first. So I'm going to go with cos of x, differentiate the second, which I've done, which is cos of x again, plus the second, which is sine of x, differentiate the first, which is minus sine of x. Okay, so we can definitely tidy this up a little bit, and I'm going to get cos squared x here. And here I'm going to get minus sine squared x. Now, we're looking at this, it looks quite familiar. Let's have a look at our identities in our log table. Okay, so I've just brought them up there on the left, and you can spot that straight away, that goes to cos of 2a, which is what I was asked for in this first part. So, happy days, we're done with that. Okay, the next one says, hence find the equation of the tangent to y equals f of x at x is equal to 11 pi over 8. All right. So we're asked to find the equation of a tangent, which we know to be a straight line. If we're going to find a straight line, we obviously first of all need to find a slope. Our equation for a straight line is y minus y1 equals m bracket x minus x1. So we need a point on it, but we also need a slope. Now, how do we find the slope of a function like this? We differentiate, which is what we've done now, and then we can just substitute in the point that we're given. All right, so cos of 2a, we are now told it's at the point 11 pi over 8, which becomes cos 2 times 11 pi over 8. So I'm on part 2 here. So if I type this into my calculator, I will get is equal to minus 1 over root 2. And you can see that there we can call is our slope. Now we're still a long way off because we have to find the equation of a tangent to a line. We have our slope, but we need our points x and y. Now they have told us that the x value is 11 pi over 8, so that's our x value, but we're looking for our y value, and how do we find that? So we're told y is equal to f of x. We know y is equal to cos 2 of x. Y is equal to cos 11 pi over 8 sine pi over 8. We type all that into my calculator and I'm going to get that y is equal to 1 over 2 root 2. So I have my x value, I now have my y value 1 over 2 root 2, and I'm going to substitute that into this here because that's what I'm asked for. I'm asked to find the equation of a line. So it becomes y minus y1, which is 1 over 2 root 2, equals m, which I found is minus 1 over 2, over root 2, bracket x minus 11 pi over 8. Okay, you're going to do a little bit of working out here and rearranging. So I'm going to multiply both sides here by root 2. Okay, so that will cancel that one out and I'll be left with root 2 bracket y minus 1 over 2 root 2 equals minus 1 bracket x minus 11 pi over 8, and then we'll just do a little bit more tidying up here. So that's going to give me, if I multiply those two there, I'm going to get root 2y. At this point here, when I multiply these out and I do a little bit of work on the side, so it is root 2 over 1 multiplied by 1 over minus 2 root 2. You can work that out yourself. Make sure you're on the right track, but you should get a half. So it would be minus a half is equal to minus 1x, so just minus x. And then we've got plus 11 pi over 8. So we're doing a little bit of rearranging there. Always we try and write it as in y is equal to or x is equal to. So I'm just going to write it as x plus root 2y equals 1/2 plus 11 pi over 8. So that is the equation of the line there. So quite a long sum there, a lot of work involved in that one. We're not finished.